Listen, here's the reality. As a software company, you build a thing, and you hope the thing that you build is used, and you hope the people that use it build something really, really cool with it. And that's fundamentally what this next talk is about. So I'd like to welcome up Brooke from Vantage to talk a bit about their journey to ClickHouse Cloud from Redshift. Oh, and you're to my right, not my left. I was looking over there like.
Thank you. Hi, everyone. I was at lunch yesterday remarking to my team that it's been a while since I've stood in front of a room with a microphone, kind of pre-pandemic, so it's good to be back. To set the stage for this, I've been a software engineer for about 13 years, mostly at the product layer, the web application layer, although I was an early engineer at DigitalOcean, so have been all over the stack, but had not worked on a data-intensive application. So I'm CTO and co-founder of a company called Vantage, and we started a bit over 3 years ago. We are a FinOps platform, which I'll go to next. What we do is we ingest cost data from various infrastructure providers. One that's missing from the slide, which we released last week, is OpenAI, which is very timely. We ingest data from all these providers. Some are CSVs, some are APIs, some we're actually querying databases directly. We normalize all that data in a specific schema, and then we make it available for our customers to analyze. We surface recommendations, we help them do optimization, cost debugging, things like that. The product generally looks like this. So once all the data is in the platform, we give them an interface to filter, aggregate, look at it on a report. Pretty similar to what a lot of SaaS applications look like these days. Most SaaS applications these days are data intensive. But like I said, this was the first one I had ever worked on personally. And then one interesting thing we do, which I don't think is typical in a lot of data applications that we use, is we let you start to drill down. And so if you are looking at a specific service from Amazon, you're looking at the cost for S3, for instance, we actually let you click into that category. We then break down those categories. So if you translate this to SQL, we're basically doing a different group by. And then you can click in again, you can click into a specific resource. And when you think about this at scale, a customer can have hundreds of millions of records per month. We store 6 to 12 months worth of data. So for larger accounts, that ends up being a billion records per account. And they can have millions of a specific resource for a specific service. And so it's kind of an interesting problem in terms of the scale of the data. But it's also interesting because of the nature of cost data. So I don't know how many people are familiar with AWS cost and usage reports, but Amazon delivers them basically every 8 to 12 hours. They are always month to date. So this CSV is for April. And so if I was receiving this on April 26th, it would have data from April 1st all the way up to the 26th. And then if I receive it tomorrow, it's going to have April 1st to the 27th. The issue with this is you have to remove all the data you had previously for April and just replace it with this. They do backfilling, they do error correction. And so there's no way to understand this line item ID is not the same to the following day. And the other thing with this is they will start to split this file. So for a large customer who's getting hundreds of millions of records per month, they'll end up having hundreds of individual CSVs. And so this is our schema. So like I said, we're taking data from all of those different cost providers. We created a standard. There is no standard in the industry. We kind of have some fields that are required that we're able to pull from all the providers, and then some are optional for the others. But the key things that I'm going to go through in the rest of the talk to take note of are the account ID, the billing period, the date, and the amount. The rest of the fields are things that you can query on. So if you want to query by a specific tag, a specific service, a specific provider, the list kind of goes on from there. We just have one big table. We're not doing any joins or anything like that, which is great. And it's all multi-tenant, and so all of our customers are just in one big schema. And most of our queries look like that, which is deceivingly simple. And so if you go back to that original report I had, it's basically just grouped by service, right? The thing being, the customer can put in, based on our interface, as many where clauses as they want. If they're querying across different providers, it ends up being a union. And so this query ends up looking pretty complex depending on what the customer has done in the interface. And like I said, with cost data, you're getting the latest month-to-date record. And so what we were actually doing pre-ClickHouse anyway, is we would delete for that specific account for that billing period, that set of data and inside a transaction, and then we would insert the current set of data so there's no duplicates and the customer is always getting the latest. So we started on Postgres, like most people do. And it kind of worked okay at first, although very, very quickly ran into some issues. And to set more context, this was a few months after we had raised our seed round, and so we were in this growth phase. And it seemed like every week or month, we were getting a customer that was an order of magnitude larger than the one we had the previous. And so a lot of that time was spent just like keeping up with the performance issues. And then eventually we just hit a wall with Postgres, and we're like, we have to figure out a different solution. And so one of the most important things with Postgres, which also ends up being true for Redshift, is the concept of a vacuum. And so unlike MySQL, Postgres won't actually delete the record from disk when you perform a delete. It just marks it as deleted, and so it won't show up in queries going forward. And then there's a separate background process called vacuum, which actually comes along and will remove the data from disk, and then that space is available for a new row to be inserted. But without that vacuum process, you end up having to scan a lot of blocks on disk to get the records, and so you do need to go back and clean them up with the vacuum job. The issue was, because we're doing this bulk delete and insert constantly for every account, for every new import we have, for every provider, the vacuum job is just constantly running, basically. And in the vacuum job, depending on the size of the table, can also be very expensive memory and CPU-wise, also IOPS-wise. The same is true for indexes. And so to make this performant at all, we needed a lot of indexes. They need to be very well indexed. And you do have to run a command in Postgres called reindex to basically do the same thing as a vacuum does for a table. And then the other part, because of the constant deletes, it's hard to keep that index in memory constantly. Basically, we're deleting all of those records that were cached in memory. They're now no longer cached in memory. And then the first query of a certain set will go out to disk. And going out to disk is usually okay, but when you're talking about millions or hundreds of millions of rows, which is too slow. Also, for context, we're on RDS, and it's an EBS volume. I think looking back, a fast fix would have been to use a database type which just had local SSDs, and that would have got us pretty far, but again, just kind of a Band-Aid on the problem. And so just an example of going out to disk versus memory. Once the results for that query were cached, or the rows in that index were in memory, the query could be less than a second, but if it is going out to disk, it could be a minute or a couple minutes. And based on our user interface, it just wasn't acceptable to have the user just wait until that query is done. This was kind of an aside, but if you do have time series data in Postgres, which we do still have, I do recommend checking out include and checking out order by in your index. The order by is very key. So if you have a date time or just a date, you can order it by descending or ascending. And then the include is great. We actually have the amount value, so we're constantly summing on amount, and so we include that in our Postgres index as well. So we started looking around at different solutions. We wanted something that was very similar to what we already had, so we could move over very quickly. We didn't want to have to learn a completely new system. The engineering team was pretty lean back then, and so we wanted something that was kind of like drop in, replace. Didn't require a lot of operational overhead. So we did evaluate ClickHouse at the time. However, ClickHouse Cloud was not around. Once we started talking about running Zookeeper and all these different pieces of infrastructure, it lost its appeal pretty quickly. And so we evaluated Redshift, and we liked it just because it was so similar to what we already had. Redshift is actually based off an old version of Postgres, and so a lot of the syntax is exactly the same. However, it is a column restore like ClickHouse, and so there was some learnings there. And this is our DDL for the table, that same table structure in Redshift. Similar to ClickHouse, Redshift has the concept of a sort key, which is a similar concept as the primary key. In ClickHouse, it is how the data is sorted. And then one intricacy difference is Redshift has a data type called super, where Postgres has JSON. And then the other part of Redshift that is actually different than ClickHouse is you pick a distribution style. And that is how the data is spread across nodes in your cluster. For our data set, because we weren't doing any joins or anything like that, it's best to just keep it even. You just want all the nodes in your cluster doing as much work as possible. You don't want any sitting idle while others are performing. And that's what the architecture of Redshift looks like. Has a leader node, and then you can have n nodes in your cluster of different sizes, and then the data is sorted on each of those node slices. Unfortunately, Redshift, while it could handle much larger volumes of data, ran into the same issues because of the nature of our workload. For Redshift to be very fast, the data just has to be sorted. And because we're doing these constant deletes, and then also as the month goes on, the amount of data we're inserting and deleting is getting more and more. And also the user wants to see the current month. That is most important to them. And so we ran into kind of some of the same issues, although not as dire. So Redshift also has the vacuum concept. They have a concept called vacuum sort, however, which Postgres does not have. And this is nothing to do with deleting data or removing dead data, but it's actually sorting the data. And so you can see the diagram from AWS's documentation there on the side, where new data as it's inserted is just appended to the end. And then you have to run this vacuum sort operation to then put the data back in order. We started by running this every week, and then we were every day, and then we were 3 times a day, just based on the volume of data we had. And then we ended up actually partitioning the tables just so these would run faster. And that's just partitioning ourselves with different tables. There is no built-in partitioning or anything like that. And then we also created several materialized views from these tables. However, we found that Redshift actually had a lot of trouble keeping up. With materialized views in Redshift, they're doing selects and delete statements just based off the base table. And it would just fall behind constantly and actually would just have to recompute the view instead of being able to do it incrementally. Also, I don't think this works. So Amazon advertises that Redshift does automatic table sort. And based on the logs I looked at, this has never happened. And there's other people on the internet who have confirmed this assumption. Because I actually thought this was true when we first deployed Redshift. And then the performance just fell off a cliff one day, and I was like, what's going on? And then I realized, oh, the data is just not sorted, because I thought it was sorting it for me. And it's referenced in this blog post and then like one place in the documentation, but there is no other reference to it anywhere. And so I actually don't know. I don't know if anyone works at AWS in the room, but so to get around these limitations in Redshift, we actually went with a hybrid architecture where we had Redshift as our data warehouse, and then Postgres as kind of our cached version of the data. And so what we would do is we would pre-aggregate all those different views we have in our product based on the customer setting a set of filters and then actually saving that report and generating that report. However, the main problem with this was the user experience. The user would have to get a very limited view of the data. They then would have to wait for the report to generate before they could start to drill in and go more deep. And then technically, it resulted in us moving just billions of records around every day between Redshift and Postgres, because the user's looking at cost data. We're basically doing like a nightly generation of tens of thousands of reports. And so that we're just basically deleting a lot of data from Postgres and reinserting a lot of the same data. But again, because we don't know what's a duplicate, what's not a duplicate, what's already been inserted, it is this wholesale replacement. And so being a cloud cost company, we are very cognizant of our own cloud costs. And our Postgres costs were higher than our Redshift costs at this point because of the provisioned IOPS and just like all of the writes we were doing into Postgres. And we could have kept scaling that, but we kind of hit a dollar value where we're like, this is we just can't go any more expensive. So we kind of just left it. Oh, and here's an example on the left of the DDL. So we ended up with like a dozen or so what we called roll-up tables, and they're just different variations on a theme, basically. So I met the ClickHouse team at reInvent this past year. And this is when we had started to think about like, okay, we want our experience to be different. The like current architecture is working, but it's a bit painful. Our Postgres costs keep going up. Like, let's start to look at what's out there and see what we can do. And again, being like a pretty small company, or lean company rather, we wanted something that was batteries included, that we could just kind of take off the shelf, not a lot of operational overhead. And so ClickHouse Cloud, I guess, was released around reInvent or something like that. Yeah. And so started to evaluate that more seriously, and actually has been great to work with. Like, I think there's a bit of a learning curve when you first approach ClickHouse, but once you understand some of the intricacies of how it differs from traditional relational databases, and how the different engines work, it's actually pretty easy to move over to. It took us, I think, 60 days in total, something like that, to move over from our current architecture and then turn on ClickHouse fully in production. And that was mostly just time spent like QA and making sure everything looks good. The big change in terms of like data ingestion and data storage is concerned is we no longer delete on insert. We actually just version the imports, because we don't have a concern of just adding more and more data into ClickHouse. And so actually make use of one of the different engines, which is replacing merge tree. And we just added this new column called import version that just increments every time data is imported for a specific account and billing period. And then when we're querying, we just take the max import version and then just do some periodic data cleanup in the background using the new lightweight delete feature. And there's not really concern around that. And so let me see if I'm missing anything else. Oh, so the big one is the first one, right? Where we're inserting data into Redshift. It's unsorted. We have to go back and run this job, which ends up being very expensive, especially as your table gets very large. And ClickHouse is just taking that data after it's inserted and doing a merge kind of automatically with that set of data you've just inserted, which is great. And I will also say, I made an assumption that this is because ClickHouse is open source, but the documentation is just far more comprehensive and technically deeper than anything you'll get from AWS on Redshift, which has just been super helpful because you can just understand how the system works. And then ClickHouse Cloud specifically, the no downtime version updates, AWS would basically be like, hey, pick a maintenance window, and then your cluster's going down. And they would also force versions on you, so you couldn't just say like, I actually don't want that. And so Saturdays at I think I picked Saturdays at noon or something like that. Every couple weekends, I would just get a page because the Redshift was down. Like no one really noticed, but it was just like this. It'd be great if this didn't happen. And then also no downtime scaling. Redshift has this weird matrix of upgrades. Depending on what instance type you are, where you're coming from, where you're going to, whether you'll have downtime or how that works, or even if you can move to a different instance type. And I just love in their documentation, if you perform a classic resize, it can be read-only for days, they say, which is just insane to me. And so you can just tell that ClickHouse is just more purpose-built for like application real-time analytics, and Redshift is trying to be more of a data warehouse, like for back office data analytics use cases. And then ClickHouse Cloud stores the data in S3, and so leaving around the old data is like very cheap. Like I said, we don't have to worry so much about getting the data out of the table to keep it performant. We're also hiring, so conveniently we're like 4 floors down from here, so it was a pretty quick commute up to the Rocked office. But we're growing pretty rapidly. We're based in New York City and also remote. We're hiring engineering, go-to-market, and design. So there's a couple of us in the room. So if you are looking for something or know someone, just come up and say hello. I know that was a little bit of a fire hose, but any questions?
Hi. When you were shopping around looking for ClickHouse, did you compare it versus anything else, or were you only looking at Redshift versus ClickHouse?
definitely looking around. The time I looked at a lot of time series specific databases, and our specific workload just didn't fit a lot of their constraints. And even something like the ClickHouse documentation is very geared towards like streaming data in constantly and not this like snapshot style. And so just from reading the documentation of a lot of stuff, you could tell it wasn't a fit. Druid seemed like the other option, but again, very operationally intense and not as batteries as included, I would say.
Thanks.
So what were some of kind of like, you mentioned like the learning curve kind of onboarding to ClickHouse was a little bit steep. Just for my sake, humor me, how can we kind of improve that? Like what were some of the difficulties you found, and like, you know, what would kind of ease the pain of transitioning from something like Redshift or Postgres to ClickHouse?
I think it's two things. One, and once you learn, it's fine, but like some things are eventually consistent. And so, which is just very good to know up front. And that is called out some places in the documentation, but I think it's something like replacing merge tree. Like you look at the initial docs for that, you're like, oh, this just right away, it's not going to be eventually consistent. So I think that's one thing. Two, it was just, like I understood primary key and sort order coming from Redshift land, that makes total sense. But how to actually then reduce the time it took for a query to execute, like I got it once I got it. Like you just want to reduce the amount of data, like which makes total sense, right? But like looking at actual rows returned versus rows that were evaluated is like the huge part. And that I don't think I saw in the documentation anywhere. That was from actually interacting with some members of the ClickHouse team.
Hey, Brooke, you've been a great partner for, we've been excited to work on this the last few months. And this can be a good segue also to Tanya's presentation next. Like, what are you looking forward to next, like in the next 6 months, maybe with ClickHouse Cloud or even for Vantage, like things you can do with your business now that you have ClickHouse, you know, on the back end?
Yeah, we already have a couple more use cases that we've brought online, and it kind of just expands your thinking a little bit when you are considering a new feature about what you can do. I mean, I think what I'm looking forward to the most is just less operational overhead, and like just less worry about that our whole data ingestion and querying process. But I'm also I did put in my slides like rate of innovation from the ClickHouse team is you can just tell based on everything going on, especially compared to Redshift, who I don't think shipped a single feature that was relevant to us in the time that we used it. But I'm actually just excited for you all to keep working on it. It's just going to get faster, I would assume, faster and better. So I don't think I have anything specific. I'm still, I think I'm still in the haze of getting on board the first time. But
One more question. If you don't mind me asking, what kind of cost savings or performance improvements have you experienced coming from Redshift to ClickHouse?
yeah, good question. So we haven't kind of like spun down or tuned down our main database yet, but I will say we have double the resources on our ClickHouse setup at similar price of our Redshift setup, and the cluster in general just does much less work in terms of CPU. And then I did have in one of my slides, basically the performance we see from ClickHouse is the same as like a hit to a really well-indexed pre-aggregated table in RDS, in Postgres. And that is cheaper than our Postgres instance as well. So it's, if you take all of the like the technical factors in as well, it's like pretty significant.
Awesome.
Awesome. Cheers. Thanks so much.